Hello, once again, Mr. Wakefield here, looking into section 8.4 now, and as I promised in the last video, we're going to learn how to add and subtract fractions now, because in that last video, 8.3, we talked about how to calculate the least common denominator, and that is the key here. As I mentioned in that same video, the denominator needs to be the same in order to be able to add and subtract fractions, but in order to be able to guarantee that it's in lowest terms, especially when you got these bigger fractions in this section, you need to not just use any denominator, but the least common denominator. Okay, so basically it's a three-step process. After you find the LCD, okay, you rewrite each fraction so that the LCD is sitting on the bottom of each one. I'll show you how to do that. Then you add and subtract the numerators together so that they become one fraction. It's similar to when you combine like terms, where there's a part that you add or subtract, and then there's a part that stays the same. Okay, and that part that stays the same is the denominator. As you can see, they keep the common denominator. And then lowest terms at the end. Okay, we need to put that final fraction that we have at the end in lowest terms if it's not already. A lot of times it will already be in lowest terms, but you got to at least check to see if it is, because sometimes it's not. So let's get started here. First problem here is a simpler one where the denominators are both single terms, and we talked about in the last section about how to do that. Let me set it up here first, though. I'm going to write it in a vertical up and down format here. It just makes it easier to set up your work. Okay. We need a common denominator, the least common denominator in particular. As we learned in the last section, we start out with the 3 and the 8 since we have only single terms in our denominators. For 3 and 8, what's the least common multiple? Well, if you write out the factors for, or not factors, pardon me, the multiples of 3 and 8, eventually you're going to get to 24 here. Okay. Fortunately, the list doesn't get that long normally, but sometimes it does. And you can see 24 is the smallest one that's on both lists. So 24 is, and I'll write it here, you'll see why in a second, but 24 what? In fact, I'll actually write it up here as well. LCD 24, there we go. And then when we do the variable part on the single terms, we pick the largest exponent. Unlike the GCF where you pick the smallest one. So that would be for x and x squared, x to the second is the biggest one. So our LCD is 24x to the second. Our goal here then is to make both of the denominators have 24x to the second instead of what they currently have. How do you go about that? What you got to do is you have to multiply by something in order to get it equal to the LCD. All right, what do you multiply 8x by in order to get it equal to 24x squared? Well, it's no different than if you had 24x squared and in a polynomial and you had to factor 8x because 8x was the GCF. Okay, you know, like when you have something like this, I'll show you. 24x squared. I'm just making this up here. Something like that, and I said, hey, factor out the LCD, and you say, okay, 8x is the the GCF. I'm thinking about LCD so much. Factor out the GCF here, and then you got to fill in this part here, don't you? Okay, well, 8x times what is equal to 24x squared? However you figure that out, you guys, however you figure out this missing term, I don't care how you do it, but however you did it here, just do it the same way here. But anyway, it's going to end up being equal to 3x. 3x. And so whatever you multiply the bottom of the fraction by, you've got to multiply the top of the fraction by. Now stop right there, though. Don't multiply it yet. Whenever you got a negative sign at the beginning of the entire problem when you're adding and subtracting, okay, if you just do 5 times 3x and ignore that thing, then that's exactly what's going to happen. It's going to get ignored, and it'll be like you're doing a positive fraction instead of a negative fraction, which obviously is not the same thing. So when you have a negative at the beginning of the first fraction, not the second fraction, that's a subtraction symbol when it's in between like that. Okay, but when it's at the beginning of the first fraction, it is when you're adding and subtracting fractions, it is going to be something where you need to put it into the numerator. Okay, we've seen before. We've seen where if you have negative divided by positive with nothing outside of it, no negative sign outside of it, that's a negative fraction. We've also seen that if you have a minus outside and no negatives on the inside, we saw this in 6.4 when we were setting up different fractions, kind of similar looking to this a little bit. But we also saw that when you have a minus in front and no negatives on the inside, that's also negative. So that's why I know that it's correct and it's okay to take that minus and put it into the numerator. Okay, it's negative either way, and so the sign didn't change based on how you repositioned the minus sign. Okay, so we're good. All right, so that's what you want to do if there's a minus in front of the first fraction in a adding or subtracting fraction problem. That doesn't happen that much, but wanted you to see that because it does happen sometimes. Anyway, I've got to multiply the top now. I get negative 15x, don't I? Like that. Then I need to do the same thing down here. What do I multiply 3x squared by to get 24x squared? Again, figure it out the same way you figured out this one here. Just like if you were factoring 3x squared out of a polynomial, and you wanted to figure out what to multiply by to get 24x squared. It's going to be just 8. Not 8x, but just 8. Because if you put 8x there, this would have to be 24x to the third. But it's not supposed to be. It's supposed to be 24x squared. So just 8 due to the fact that the exponents are the same there, x squared and x squared. All right, don't multiply by another variable there. Now, the way you do this here when you're subtracting fractions, do not bring the minus sign into the 2 when you're multiplying. Okay, do not do that. That is subtraction when it's in between the fractions like that, when you're subtracting fractions. All right. I know sometimes you incorporate the minus in front when you're multiplying in some problems, but don't do it here. Okay, that will cause some problems. I'll kind of talk about that later. But just do 2 times 8. And then the minus here that's in front of the second fraction, that simply means to subtract. What are we subtracting? Well, now that the denominators are the same, and you're not allowed to do this until they are, but if they are the same, you're allowed to subtract the numerators now, the brand new numerators that you got. So it'd be negative 15x minus 16. What does that equal to? Well, remember we talked about on the first day of class that if you're subtracting 2 terms that are not like terms, do not combine them. Just say that they're being subtracted like this. See how I didn't combine them into one term? I just said that they're being subtracted. All right. I have to still say that they're being subtracted and put them together in that way so that they're still separate, but they're still brought together as a polynomial. I have to do that because when you do the step here where you subtract the fractions, you've got to be able to produce a single fraction. And so that's why I got to bring them together in the brand new numerator that I have here. Okay. And then the denominator stays the same. Okay. So just like when you're combining like terms, all right, something is the same and then something stays the same. All right. When we did the like terms before, okay, the first day of class, the x squared is the same, and then it stays the same, and then you combine the coefficients together to get 10. Same idea here, only now it's the denominators that are the same, and then they stay the same. A very close relationship there between this and the first day of class. And then instead of the coefficients, it is now the numerators that you are adding or subtracting. In this case, subtracting, because it's a subtraction problem, as we can see in the middle there. Okay. So now I've got, so again, you subtract the numerators, you keep the denominator the same, and then you take the resulting fraction you have left over and you put it in lowest terms, or at least try to. Well, in order to do that, I need to factor and identify my factors and then cancel if I can. If you have a single term in your numerator denominator, such as 24x squared, as we learned in 8.1, that means that it is going to be a single term factor as well. Okay, it didn't break down to two or more things. On top, we have a prime polynomial because the GCF is 1, and we have two terms with x to the first power. When that happens, okay, after you do the GCF, if you still have two terms with x to the first power, after you try to factor out the GCF, as we've said before, you can't factor that any further. So since the GCF is 1 also, that's prime. Nothing happened. And so what we end up with here is a red factor, because this is one single factor, since it didn't break down to two or more things being multiplied together. And so that's a single red one, since it's got more than one term, and then this is a single green one. And as you guys know, you can never cancel a red and a green. Not even part of the red can be canceled with the green. Another thing we learned in 8.1. So this thing is already in lowest terms due to the fact that we can't cancel anything. Okay, and that's why I'm going to circle that there. So the last step is to try to put that answer in lowest terms. Now things are going to get a little bit more involved due to the fact that our problems are bigger. We've got denominators that have more than one term. That's a big thing. I'm going to set it up here again. What I'm going to do, though, while I'm setting it up is factor your denominators, because we're going to need to know. We're going to need to do that in order to figure out the LCD, which is the first step. T plus 7 is prime. So that's just one red one right there. T squared minus 49 is T minus 7, T plus 7. Because it's T squared minus 7 squared, right? I'll put the numerators in there as well. Like that. There we go. This is two red ones here, because it's just the two brackets. Based on that, you guys, what is the LCD? Well, there's no green ones here, and so as we learned in the last section, when you get to the red part, you just put all of the different red ones in there. As long as none of them appear more than once in the same denominator, you just put all the different ones in there. And so the LCD is these two things, T minus 7, T plus 7, because those are the two different ones that you have here. Three total red ones, but there's only two different ones. Okay, so what you want is you want your LCD, your denominator, for each fraction to be the same, and you want it to equal the LCD. Like that. Okay. All right. So now I need to multiply by the appropriate things, just like I did over here with 3x and with 8. I need to multiply by the appropriate things in order for the denominator to be equal to the LCD. You can see here in the first one, T plus 7 is already one of those two things that's in the LCD there. If you've got two factors in the LCD, you guys, and you can see we do, two red ones there. If one of those two red ones is already you're equal to your denominator, wouldn't it make logical sense to just multiply by the other red one? Okay. It's okay that it's in an opposite order because we're multiplying. Okay. We're multiplying. And so this right here is the same thing as this. Okay. And even if you don't put a bracket around this, it's when you're multiplying something by the denominator, it's automatically implied that there's an invisible bracket around it. You can put the bracket there if you want. It's just that it's already implied that it's there because you're supposed to multiply by the entire denominator. Anytime you multiply by the denominator, you're multiplying by the entire denominator. And since it's got two terms, you could keep those brackets invisible, but they are there. So I'm just going to make them visible to make it easier for us to follow. Okay. Now, since I multiply the bottom by t minus 7, I want to multiply the top by the same thing. Now this next part here is really important. Okay, again, you got to put the t minus 7 in brackets because it's got two terms and you're multiplying it by something. And we've said that many times, right? It's got more than one term and you're multiplying by something, so you got to bracket the t minus 7. Okay, that reminds us now that when I figure out what the brand new denominator is, and this is different from 8.1 and 8.2, you do need to get rid of the bracket here. We're not trying to put this fraction in lowest terms. That's for later in the problem. So we do need to get rid of this bracket here so that I can then add the fractions together on the next step. If the brackets are there, you won't be able to do that. So when you figure out the brand new numerator here and the brand new numerator here, okay, you're going to need to get rid of those brackets on the top. Not the bottom. The bottom is fine to have the brackets, but the top, in order to be able to add the numerators together, just like I did with negative 15x and 16, I need to be able to get rid of those brackets to see if anything combines. So when you got a single term times a bracket, don't you distribute in order to get rid of the brackets like we've done in many equations over the last over the entire class and previous problems that we've done? Okay, that's how you get rid of those brackets. And we get t squared minus 7t. So that's what you want to do to get rid of those brackets. Okay. Now notice down here, the LCD is already sitting in our denominator. So as they say, if it ain't broken, you don't fix it, right? It's already got what we want in the denominator. It already is equal to what we want, so don't multiply by anything. Don't change anything. And so therefore, since the denominator doesn't change, it also makes sense that the numerator wouldn't change either. It's when the denominator is not equal to the LCD, that's when you got to multiply by something here. But when it's the same, you don't. Okay, so now that the denominators are the same, I can add the numerators together. Since it is an addition problem, I'm going to add here, right? Okay. How do you add two polynomials together? Okay. The way you add when, again, this is assuming that there's no brackets in your numerators here. The way you add two numerators together, just like we did on the first day of class, even though there's no brackets here, all right, it's the same idea. When you have two numerators that are polynomials, when you add two polynomials together, you just combine like terms. No sign changing. That's for subtraction. I'll get to that here in a minute. Okay. What do we get here? If I combine like terms on these two numerators, I get t squared plus 2t and then the minus 35. The t squared and the minus 35 didn't combine with anything, but those other two terms became 2t. Please put it in this order when you have a variable being squared and then a variable to the first power and then no variable at all. If you've got those three kinds of terms, please put it in that order, because remember, when you put the problem in lowest terms at the end, you've got to be able to factor if possible. And so you got to give yourself a chance to factor by putting this in a factorable form. Okay, putting this out of order here, not in this order here, you wouldn't be able to even have a chance to use the Berry method, which is what you would normally use here, isn't it, when it looks like this? Okay, so you want to put those terms in that order. Okay, t squared, t to the first, and then no t at all. If those three terms all appear in your brand new numerator, that is. That didn't happen over here, so that was different. It was just two terms. But when it's those three types of terms, put it in that order. Then try to do the Berry method when that happens, and we'll see if we can cancel something. The bottom, by the way, if you do the LCD in the normal way that I show you here, okay, the LCD should already be factored already when you get down to this step. And so you don't need to factor that. Remember, when we put things in lowest terms, we got to factor the top and bottom. My point is that if you do this in the normal way, the denominator will already be factored for you, so you just need to factor the numerator before you try to cancel something. Can I factor this numerator? Yes, I can, because 1 times negative 35 is negative 35, and we know that 7 and negative 5 add up to positive 2 in the middle from negative 35. So we're going to get what here? We're going to get t plus 7 and t minus 5. Okay. And again, the denominator stays the same there. That's already factored like I just mentioned. This is 2 factors right here, 2 red ones. We already have the 2 red ones on the bottom. Can I cancel anything here? Yes, I can. There's 2 things that are exactly the same here, this one and this one. And so, yes, it was necessary to put this in lowest terms this time because it actually was not in lowest terms when you first got that fraction here on this step. Okay. A lot of times it already is in lowest terms, but we need to try to get it into lower terms to find that out. And we just found out that it's not in lowest terms. But now it is, though, after I clean up these slash marks and write out my answer. I have 1 times t minus 5. And as I mentioned previously in Chapter 8, when you have 1 times a bracket, you don't need to write the bracket there anymore. It's just the inside of the bracket. Same thing here, t minus 7 times 1, it's just equal to t minus 7. And that is your final answer right there because we got it in lowest terms. Okay, so that is how you add fractions. All right. But again, the goal here is to make the denominators the same, okay, by multiplying by the appropriate thing. And sometimes you don't have to multiply in like a fraction like this. Once the denominators are the same, you add the numerators together or subtract them if it's a subtraction problem like over here. And then you put the answer in lowest terms right here. Okay. Now, the good news is that when you get to the subtraction problems, okay, the entire process is exactly the same with one major exception. We've got to watch out for that. Okay, I'll show you that major exception when we get to it, but the beginning of the problem is exactly the same. So I'm just going to jump right into this since it's exactly the same as the last problem, at least the beginning, like I said. So what we do when we start writing it in this vertical format from top to bottom here is factor your denominators first so that you can then figure out the LCD right away. 1 times negative 12 is negative 12. What 2 numbers add up to 4? That would be 6 and negative 2. So that's going to be C plus 6 and C minus 2. And those brackets both have a GCF of 1, so the last step of the Berry method is not necessary. This one right here, 1 times negative 24 is negative 24. The 2 numbers that add up to positive 2, sorry, there we go. The 2 numbers that add up to positive 2 in the middle are 6 and negative 4. So we end up with C plus 6 and C minus 4, like that. Okay. Now that I have factored my denominators, I now can figure out the LCD, just like in 8.3. Okay, you got to factor first when your denominators have more than one term. Once again, we just have a couple of red ones inside of each denominator. Okay, since there's no green ones, we jump right to that step where we figure out how many different red ones do you see there. I see 4 total red ones, but I see only 3 different red ones because these 2 are the same. Okay, and so I'm going to put those 3 red ones into the LCD. In other words, that is the LCD, is those 3 red ones. Again, it does not matter what order you put these 3 brackets in because they're all being multiplied, so it's the same no matter what order you put it in. Okay, like that. Okay. So here's the thing. The LCD has 3 red ones in it now. Okay. Because you took the 3 different red ones from the problem. When you have 3 red ones, 3 multiple term factors inside of your LCD, and 2 of those 3 red ones are already sitting in your current denominator, you can see that the 2 that you see here in the denominator are already over here. It's just that there is now C minus 4 over here. So wouldn't it make sense that if you have 3 in your LCD and 2 of them are already in the fraction you're doing, wouldn't it make sense, kind of like the last problem, that you would just multiply by the missing one? The missing one here is c minus 4. Okay, now I have all 3 of them here just like this. Okay, so multiply by the missing one, okay, if you have 3 red ones and 2 of them are already there. So that means I need to multiply the top by c minus 4. All right? Remember, just like in the last problem, if you've got a single term being multiplied by a bracket with more than one term in it, like c minus 4, and again, I need to bracket this c minus 4 because it's got more than one term and we're multiplying it by something. But just like over here with the t minus 7, if you've got a single term times a bracket, you need to distribute the 3c through this bracket. What do we get if I do that right there? Like that. What do I get? 3c squared minus 12c. Okay. And now we need to do the other fraction. Notice again that we've got the 3 red ones in the LCD. 2 of those 3 ones are already over here. The first one and the third one from the LCD are already sitting over in the denominator now, and so the missing one is c minus 2. Okay? So it would make sense then that we would once again multiply by the missing one. Like this. Okay? Now here's the thing. When you multiply by c minus 2 in the numerator, because remember, you can't have any brackets in the numerator when you're adding and subtracting. Before you actually get to the point where you combine the numerators together, you've got to get rid of those brackets in the numerator. Just like we did over here with the t minus 7 and with this first numerator in this problem. Okay, but remember, when you multiply by c minus 2, you need to multiply the entire numerator by that. And so since that numerator's got 2 terms in it, I'm going to bracket that to remind myself of the fact I've got to multiply by the whole thing. I didn't bracket the t or the -5 or the 2 or the 3c. I didn't bracket any of those numerators because they only were one term. Okay, so if you're multiplying your numerator by something and that numerator already has more than one term in it, 2c minus 5 has 2 terms, put a bracket around that to remind you've got to multiply the whole thing. Okay, and that also reminds us that when you've got a bracket with 2 terms in it right here being multiplied by another bracket that has 2 terms in it, it is similar to all the way back in 6.3, 2 terms times 2 terms. Okay, you multiply that out, 4 different multiplications. All right, and then that's how it's going to come out. You're going to get those 4 different multiplications. In other words, you do 2c times c. Do not do anything with this minus yet, just like in the first problem. Don't touch that minus that's in between the fractions there, because that's a subtraction symbol. Don't do that until we actually are ready to subtract the numerators. We're not doing that yet. We have to figure out what the numerators are first. Okay, so don't try to put this up here into the 2c minus 5. Okay, we did that when it's in front of the first fraction, but not when it's in front of the second. That's a different story. Okay. 2c times -2 is -4c. -5 times c is -5c. And finally, -5 times -2 is +10. Okay. Now, we now need to subtract those numerators since it's a subtraction problem. And since the denominators are the same, we are ready to do just that. We can subtract the numerators when the denominators are the same. Okay. But here's the thing. Since it's a subtraction problem, we got to do things a little bit differently. Remember these problems here in 6.4 when we were doing long division? Okay. And originally it looked like this. I'll just take this problem as an example. 6y times 2y plus 1 was equal to positive 12y squared, positive 6y. So it originally looked like that right there. But because I need to subtract on that step, I need to change the signs of the second line right there, don't I? Okay, in other words, it's the first line minus the second line, and so it's the thing you're minusing, the second line, that you change the signs on. Same exact thing happens here. Okay, we've got the first numerator minus the second numerator. So since it's a subtraction problem, we are going to change the signs of all of these terms on the second numerator before we combine like terms, just like what we did in long division. Okay, remember, after I change my signs right here, I combine like terms. Same thing happens here with the numerators. Okay, so this becomes negative, positive, positive, and finally negative 10 on the end. Okay, everything changes signs. Then once it does that, now you can combine like terms, just like in long division. Okay, and remember, we did not do that over here because it was already an addition problem. It's when it's subtraction, okay, that you got to do that. Addition, you don't change signs in the numerators. Subtraction, you change signs of the second numerator, just like you change the signs of the second line when you're doing long division. Okay, what do we get? C squared, when I combine like terms with those two. Negative 12c, 4c, and 5c is going to be minus 3c. And then minus 10 doesn't combine with anything, so I just bring that down behind that. And there you go. The denominator stays the same. Like that. Okay. And remember, if you have c squared, c to the first, and no c at all in the last term, make sure that it's in this order if it's not already, so that you can try to do the Berry method on that and see if something cancels. So let's do the, remember, like I said, if you do the LCD the way I've been doing it here, it should already be in factored form. Okay, we've got 3 prime brackets here. That's you can't factor that any further. Okay, if you've got nothing but brackets being multiplied together, no GCF or anything, or even if there was, if you've got nothing but brackets being multiplied together, and they're all prime, then that is already completely factored. You can't possibly factor the LCD anymore. But if you do the LCD in the normal way that we're doing it here, it's already going to be factored anyway, so don't worry about that. I'm just double checking that for you, okay? Just making you confident that it's already factored. But you don't have to worry about it if you just do it the way we normally do. The denominator should already be factored. But the numerator is a different story, just like in the last one. We got to try to factor that. 1 times negative 10 is negative 10. In order to add up to negative 3, we need to use negative 5 and positive 2. And so we end up getting c minus 5 and c plus 2. And now the top part is factored. Does anything cancel between the top and the bottom? Actually, it doesn't, okay? I know it comes close to canceling, but nothing cancels there. None of those red ones cancel. No, you cannot cancel these two right here, because when one of the two terms has the same sign and the other two terms do not, 2 and negative 2 are different signs, c and c are not different sign, they're same sign, then you can't cancel those when one is the same sign and the other one isn't. So we tried to put it in lowest terms, but since nothing cancels, it is already in lowest terms. Okay, and so that's your final answer right there. You could, since nothing canceled, you could, like I promised you, you could multiply this thing back out, okay, and put it back the way it was before. All right, like I said when we were talking about lowest terms, as long as you're sure that you have canceled everything that you possibly can, you can get rid of your brackets after that. It's just that you don't have to. So you can leave it like this if you want. I promised you could when you're doing lowest terms. You can keep the brackets in the answer, but you could also write it like this if you want to. Since nothing canceled, you can multiply these two brackets back out again, and it would end up looking like this. Okay. So either way is fine. Okay, so that is, again, you can see here that the process is the same for adding and subtracting. And one big difference is that when you add the numerators together after the denominators become the same thing. After you add those numerators, when you add those numerators together, no signs change on either numerator. You just combine like terms. But when you're subtracting, because this is a subtraction problem here, when the denominators are made the same, you take your numerators, make sure the brackets are cleared out in the numerators, but then you take those numerators and you combine them, but not until after you change the signs of that second numerator that is being subtracted here. Not the first one. That keeps the same signs that it was before, but this changes, okay, before you combine like terms and get this right here. Okay, so please try problems 1 and 2 down here. You can skip number 3. We're not going to do that one. Okay, we're not going to do any 3 fraction problems right now. So we're just going to do 1 and 2. Give that a try. Okay, again, this one's addition and this one's subtraction. So you now know the difference. Okay, and so go ahead and do that accordingly. All right. Hit the play button after that, and we'll take a look at those answers. Okay, let's take a look at number 1 here first. I set it up in the vertical format right here. Okay, there we go. Set up in the vertical format right here, and I put brackets around the numerators here, even though they weren't there before, just because they have 2 terms, and I know that I'm going to be multiplying them by something here eventually. So just like in the last problem, I put those brackets there to remind me that I've got to multiply the entire numerator. Okay, a lot of students will forget to do that. They'll just multiply -2 times whatever you're supposed to multiply by over here. In this case, it's going to be x plus 3. I'll explain that in a minute. But putting that bracket around it reminds you got to multiply this whole thing. Okay. Anyway, how did I get this LCD up here? Why is that the LCD? Well, after I factor my denominators, I get these 4 red ones. Okay, these 4 red ones, there's 3 different ones out of those 4, isn't there? Okay, x minus 3 appears twice. And so that for that reason, my LCD is going to have all the different ones in there. Okay, and that's why this is the LCD right here. So then in order to make my LCD be equal, or in order to make my brand new denominators to equal the LCD, in order for the LCD to land into the brand new denominators here for both fractions, I need to multiply by what here? I need to multiply by x plus 3 on this one, because again, remember what we talked about, you guys. If your LCD has 3 brackets in it, and 2 of those 3 brackets are already in your current denominator, it makes logical sense to multiply by the missing one. X plus 3 is the missing one here out of this denominator. So I'll multiply the top by x plus 3 also. Okay, and just like in the last problem when you got the 2 brackets, the one that's in the numerator, because it's got 2 terms, I put a bracket around it. And this one, I put a bracket around it also because it's got 2 terms, and it already had a bracket around it anyway. But it has to have one because it's got 2 terms, and you're multiplying it by this. Okay. So multiplying that out, 2 terms in a bracket times 2 terms in a bracket, you do the same thing we did before. Do the 4 multiplications. Here those 4 multiplications are right here. You don't need to combine like terms on this yet. Okay, we're going to do that anyway when we combine the numerators together, so there's no need to combine these yet. It'll all come together in the end. Okay, we do the same thing down here. X plus 2 is the missing red one here in the denominator for the second denominator, the second original denominator. X plus 2 is the missing one. And so we multiply the top and bottom by that so that the bottom then will have all 3 parts of the LCD in it. Okay. And so we multiply the top out right here. 2 terms in a bracket times 2 terms in a bracket here. Again, we get 4 multiplications right there. Okay. Again, just like up here and just like the second fraction in problem C. All right. 2 terms times 2 terms. 4 terms total. Now, since it's an addition problem, and since my denominators are the same now, I can now add the numerators together. When you're adding numerators, there's no sign changing. You just combine like terms, and that's it. Okay, what do we get? There we go. We get, and go ahead and put it in this order right here when you got x squared and x and no x at all in your numerator. Put it in that order so you can try to do the Berry method. Okay. The reason why I underline that, though, as one big red factor is because it's actually prime. And the reason why I know that is because 7 times negative 12 is negative 84. But then when I try to find two numbers for negative 84 that add up to the middle number 12, there isn't a pair that works. And because the GCF is 1 for this thing on top, and since the Berry method doesn't work after doing the GCF step, that means it's prime, right? We couldn't factor it at all. And so when you got a polynomial with more than one term and it's completely prime, that's one big red one there. And therefore, it doesn't cancel with any of these red ones down here. It's not, it doesn't fit with any of those at all. Okay. But you had to try. You had to try to factor to try to see if it could get into lower terms. Okay, since nothing cancels, it's already in lowest terms, and that's why I circled it. Okay, so that's addition. Subtraction. Okay. For subtraction, the LCD is going to be this right up here. Okay, be careful. This second one is tricky for a lot of students. A lot of people will say, oh, I need to do 2 and 3, right? Not 6 and 1, but 2 and 3 is mine. No, no, no. Okay, 2 and 3 would work if this was plus 6. Okay, then you would want to do minus 2 minus 3 if this was plus 6. But since it's minus 6, what ends up working is negative 6 and plus 1, and that's why I put that down here when I factored them. Okay, again, very easy mistake to make. Be careful. Okay. So since this is my LCD, due to the fact that there's 3 different red ones, 4 red ones total, but 3 different ones, x minus 6 appears twice, so there's 3 different ones. Very similar to the last problem where it had 3 different ones over here as well in the LCD. But because that's my LCD, I need to multiply by the appropriate thing. Let me erase this off here. I want to do that by hand instead of just showing it to you because it did 2 steps in one right there, and it's hard to follow that unless I do that by hand. Okay, so I'll put that in there in just a minute, but let's look at the top here. I needed to multiply by x plus 1 because, again, the LCD has 3 red ones in it. You can see I highlighted those 3 red ones up here. And out of those 3, 2 of those 3 are already in your denominator, and so I multiply by the missing one, which was x plus 1. X minus 6 and x minus 1 are already sitting here, and so you just pick the one that's missing and you multiply by that, x plus 1. And so now I need to multiply the top by that same thing. Since my numerator has 2 terms, and since the thing I'm multiplying by has 2 terms, it's just like the last problem over here, okay, where you have 2 terms times 2 terms. All right. And that leads to 4 terms up here. All right. Don't need to combine like terms yet. So you can keep these 4 terms the way they are. And then like I mentioned in problem C before we tried these numbered problems here. Actually, let me go ahead and explain the x minus 1 here first, and then I'll mention that. X minus 1 is the missing factor this time because these 2 factors are already in the LCD, but x plus 1 has not been accounted for yet. I'm sorry, x minus 1 hasn't been accounted for yet. The minus 6 and the plus 1 are already over here. So the one that's missing over here on the left to make it equal to this LCD is x minus 1. So I multiply by x minus 1. And if I do that, I get this, x squared, x times x. Again, do not bring this minus in there yet. Okay, that's for when that reminds you to change signs, but you're not supposed to distribute that through. Okay, X times negative 1 is negative x. 3 times x is 3x. And then finally, 3 times negative 1 is negative 3. All right, now. So that's what you get when you multiply. But since this is a subtraction problem, just like we did in problem C, after you do your multiplication, since this is the denominator that's being subtracted, this one minus this one, the one that's being minused here, you need to change the signs of all of those terms. Okay? Minus, plus. Changes the sign of all four of them. Minus, plus. And now I can combine like terms. If I combine like terms, okay, I get x squared, the 2x, the x, and the minus 3x, all four of those terms there that are x to the first power right there, they combine together to be equal to 1x. And then 1 and 3 gives you plus 4 right there. Plus 4. Okay. And just like in the last problem, you can try to factor this thing with the Berry method, but nothing works. So that thing is prime right there, since the GCF is also equal to 1. And it does, nothing cancels with this. A very similar looking problem to the last one. Okay, you just got to remember to change those signs when you do the part where you got to combine the numerators together. All because it's a subtraction problem. Speaking of minus, want to go back to the first problem there just for a moment. Let me pull that out here from where I wrote it down. Why did I not do any sign change in here since this was subtraction? Well, you don't have to do that when it's just a single term. Because notice right here, this is positive 16 right now before you incorporate this minus sign, right? So it's positive 16, and then it became negative 16. So it still changed signs like it's supposed to. It's just that when it's just a single term, if you just say minus 16, just how it looks, it ends up changing its sign anyway, okay? So you don't have to worry about like making sure you change the sign when it's just a single term like that. The 16 will turn into minus 16 just by saying minus 16. Okay, it's when you have more than one term in your numerator that you're trying to subtract, like this one right here, and like in problem C. That's when you got to change the signs very carefully, because you got to change the signs of all four of these terms. You don't just have a single term in your numerator this time like we did in problem A. You've got a whole bunch. Okay, so we got to change the signs of all of them. Okay, a lot of students, they'll get careless about that and they'll say, oh, it's subtraction, so then they'll just put a minus in front of the first term here to change it from x squared to minus x squared, and then they'll forget to change the signs of these, and that completely ruins the problem. You got to change the signs of all of the terms, okay, when you've got more than one term in that numerator that you're subtracting. Okay, so that concludes adding and subtracting fractions. Okay. Again, very similar format here. Just be careful with those subtraction problems to change the signs. But let me know if you have any questions about 8.4. We'll be doing a lot of these things here, though, in 8.5 that we've done in the entire chapter, Chapter 8 so far. So let me know if you have any questions about anything from Chapter 8 as we move on towards 8.5 in the next video, okay? But in the meantime, though, have a good day and take care.